This is the tutorial for Chapter 7, Section 4, titled Approximating Square Roots. And today we're actually going to do what the title says. We are going to approximate square roots. We're going to estimate those square roots to the nearest integer, and then we're also going to estimate them to the 10th place. And so when we go ahead and do it, we're going to end up using this calculator to justify our answer in just a moment. But what we're going to do first, though, is we're going to want to know some perfect squares. And so it's a good idea to commit to memory these perfect squares. It makes life a whole lot easier. Now, none of the problems that we have here, or that you're going to end up seeing, deal with such difficult numbers. But I am going to add one extra one in. I'll add a fraction one in, just to try something that might be a little bit more difficult. So we've got square roots of 1 through 25, or squares that are 1 through 25. So for instance, square root of 1 is 1, the square root of 4 is 2, and so on. So good ones to remember, and we need to know those in order to figure out, or in order to estimate. So the first thing you're going to do when you estimate is find the perfect squares that your value, your radicand, is between. So the ones that it's between are this: 4 and 9. Those are the perfect squares. See, 4 and 9 right here. And so what that tells me is the square root of 4 is 2, the square root of 9 is 3. I know the square root of 8 is in between, so it's going to be a number that's in between. So the integer, so estimate the square root to the nearest integer. So part A, we would say that value, the nearest integer, since 8 is closer to 9, I know it's going to be closer to 3. So for this answer, it would be positive 3. That would be the answer to the nearest integer. Now to the 10th place. So what you do for this is, I end up using a mixed number rather than a decimal to start with, but we can change that mixed number to a decimal. So I know it's going to be 2, and it's going to be some sort of fraction. Now the way I do it is I subtract the radicands. So 9, the perfect square radicands. Subtract those and you get 5. That's going to be your whole number. And then I subtract the radicand that you want here, 8, from the smaller of the two. So 8 minus 4, and I get 4. And so you can oftentimes do that part in your head. And this is a good approximation. So it's not in the 10th place, but we can estimate what this is. So 4/5 is an easier one. It's 2.8, and that's a good approximation. So I would say B is about 2.8. So that's going to be even a better approximation than the number 3. Let's check and see if that's correct. So here it is. We plug in 8, and the radical sign, there it is, 2.82. So it does round to 2.8. So let's try another one here. Clear that. And this is the opposite of the square root of 13. So I find the ones it's between. So ignore the negative sign for now. We'll just find out what the square root of 13 is, and then just put a negative sign in front at the end. So the square root of 13 is between these two perfect squares, 9 and 16. So I look to see which one is it closer to. So you could actually do the subtraction now. 16 minus 9, and I guess I could go ahead and tell you what the square root of 9 is. It's 3. Square root of 16 is 4. So I know square root of 13 is going to be in between these two values. 16 minus 9, well, that leaves me with 7. So I know it's going to be 3 and something. It's going to be 3 and something sevenths. So I subtract 13 or 9 from 13, and that gives me 4. So I see that 4 sevenths is over 50%. See, 3.5 over 7 is 50%, is halfway in between. So it is closer to 4. And you can see 13 is closer to 16 than it is to 9. So the answer would be negative 4 because it's the opposite of that square root. Now to find out what this is close to, well, this one ends up being about 3.57. So if you do that work, it ends up being a little over 3.5. So a good approximation would be 3.6. So let's see how close we are. So negative 3.6 is a good approximation. So let's see if that ends up being about right. So we take 13, and we take the square root of that, and there it is, 3.6. And it's negative, so it's negative 3.6. So very good approximation there. So this one is in between the square root of 16 and the square root of 25. Again, we're going to put the negative sign in there at the end. So the square root of 16 is 4. Square root of 25 is 5, so I know the answer is going to be in between. This one's easy to find out which one it's between because 24 is a lot closer to 25. So I would say for the nearest integer would be negative 5. Now the number's actually smaller than negative 5, so let's do that approximation. So subtract the two radicands, the two perfect square radicands, and that gives us 9. And then I can subtract the one I'm looking for from the smaller of the two perfect squares, and that gives me 8. So a good approximation in mixed number form would be negative 4 and 8/9. Well, as a decimal, that would end up being negative 4.8 repeated. And so it's going to be pretty close to negative 4.9. Let's see how close we are. So let's pull up the calculator, and we'll enter the square root of negative 24. We'll just do 24 radical sign, and there it is, 4.89. So you can see how close it is to negative 4.9. So again, the negative sign just because we have the opposite sign right here. So square root of 110, a little bigger number. So the perfect squares are 81, and oops, not 81, bigger than that. So let me fix that. 100, and the square root of 121. And so the square root of 100 is 10. The square root of 121 is 11. So I need to find which one it's closer to. So I'm going to look at these two numbers, and I see that, let me go ahead and do the subtraction first. 121 minus 100 is 21. So I know it's going to be 21 is the denominator, and then 110 minus 100 leaves me with 10. So I can see that 110 is just a little closer to 100 than it is to 121. So for part A, I would say it's going to be about 10, closer to 10. Now for part B, we're getting really close to the 10th place. We would write that as 10 and 10/21. Well, 10/21 is really close to 0.5. So if I do that division, that ends up being just about 0.5. It's going to be like 0.4 something, 49 or something like that. You see, if you do the division 10 divided by 21, gives me 0.47, so it's really close to 0.5. So 0.5 should be a good approximation. Let's check to see if it is. So we'll plug in 110 and do the radical of that, and there it is, 10.48. So you can see how close this answer is to the answer that we got. So 10.5 is a good approximation. So that's the way I estimate square roots without a calculator. And good luck on tonight's homework.